Hey everyone, welcome to this explainer. We're jumping right into the fascinating and honestly kind of complex world of Friesian horse genetics today. Specifically, we're going to focus on how we can use science and structured knowledge to safeguard our beautiful breeding mares. If you are focused on doing right by your horses and want to learn exactly how modern genetic tools apply to the day-to-day care and breeding of Friesians, you are absolutely in the right place.
So, think about this for a second. How do you protect a magnificent breed that, at one point in history, literally dwindled down to just 3 breeding stallions? Sounds completely impossible, right? The stakes involved in Friesian breeding are incredibly high, and the biological challenges we're facing today are a direct result of that dramatic history.
Okay, let's dive into our roadmap for today. We'll be looking at the genetic bottleneck, recessive mutations, foaling vulnerabilities, genomic testing, and finally, safe breeding strategies. Starting with Section 1, the Friesian genetic bottleneck. To really grasp the genetic health of our modern mares, we have to look back at their historical fight for survival.
So, the KFPS registry kicks off in 1879, but by 1913, the breed was staring down extinction. There were only 3 registered breeding stallions left on the planet. Even as recently as 1965, we were looking at just 500 registered mares. Fast forward today, and thankfully we have over 45,000 registered worldwide. They made it. But, as you can probably guess, rebuilding an entire global population from such a microscopic genetic pool came with a pretty heavy cost.
Because we rebuilt from that tiny foundation, we're now dealing with a staggering 16% average inbreeding coefficient across the breed. To put that into perspective, the inbreeding rate creeps up by about 1.5% every single generation. And considering the recommended limit for maintaining genetic variation is just 1%, yeah, we are way past that. This lack of diversity is exactly what sets up our Friesians for a whole host of hereditary and systemic conditions.
Which brings us to Section 2, recessive mutations and risks. Because of that limited gene pool, Friesians face some serious hidden threats.
To really wrap our heads around this, let's quickly define what an autosomal recessive mutation is. Basically, it's a genetic condition where a foal has to inherit one mutated gene from each parent to actually get sick. The real tricky part here, the hidden threat, is the carrier. A carrier has one normal gene and one mutated gene. They look perfectly healthy and show 0 symptoms. But if you accidentally breed 2 carriers together blindly, you could inadvertently pass on some truly devastating, even fatal traits to the foal.
And this brilliantly illustrates the clinical data on those primary genetic traits. It breaks down the genes involved and the physical realities of conditions like dwarfism and hydrocephalus.
Let's quickly break down the major mutations you need to know about. First up is dwarfism, which is caused by a glitch in the B4-GALT7 gene. This leads to severely stunted growth. We're talking 25% shorter limbs and hyperextended fetlocks. The breed currently has a 12% carrier rate for this. Next is hydrocephalus, linked to the B3-GALNT2 gene. This is just heartbreaking. It's a fatal buildup of fluid in the brain, carrying a 17% carrier rate. Finally, there's dystochiasis, an inherited disorder where extra eyelashes grow completely abnormally and end up damaging the cornea. If you skip genetic screening, these are the exact stakes you're risking.
Moving on to Section 3, foaling and systemic vulnerabilities. Let's pivot and really focus on protecting the pregnant mare from her own unique health risks.
Recent advanced research has uncovered something absolutely crucial. To quote the studies, healthy Friesian horses show an increased connective tissue turnover. Mutations manifest themselves on top of an aberrant connective tissue metabolism. Simply put, our beautiful mares are uniquely vulnerable from the inside out. Their connective tissues and ligaments are just fundamentally different from other breeds.
And because of this underlying weakness in collagen and elastin, Friesian mares suffer a shocking 54% rate of retained placenta after foaling. 54%! If you own a mare, that number should be a massive wake-up call. It literally means you need to have proactive veterinary care locked in way before labor even starts because your odds of a retained placenta are actually worse than a coin flip.
There's another, incredibly grave risk here too. Breeding a hydrocephalic foal isn't just a tragedy for the offspring. Because of the severe cranial distension, the massively enlarged head of the foal, it physically endangers the mare's life during foaling. It creates a severe risk of fatal dystocia. Protecting your mare means making absolutely sure she is never, ever put in the position of delivering an affected foal.
It's also worth noting that this abnormal connective tissue is tied to other dangerous systemic issues across the breed. We're talking megaesophagus, which causes severe chronic choke, aortic rupture, which is a sudden fatal tearing of the main vessel leaving the heart, primary gastric rupture, and overall tendon and ligament laxity. All of it stems from that exact same collagen issue.
I know that sounds incredibly daunting, but we are definitely not helpless here. Let's move to Section 4, Genomic Management and Testing, and see how science comes to the rescue.
Now, what's really interesting about this slide is seeing how governing bodies like the KFPS and FHNA have stepped up. They've implemented strict, mandatory DNA screening rules for breeding stock just to identify the carriers of these specific conditions.
Now, you might be sitting there wondering, well, if we know who the carriers are, why not just ban them from breeding entirely? It's a fair question, but here's the catch. With only about 100 approved Friesian stallions globally, eliminating all the genetic carriers would dangerously constrict an already tiny gene pool. If we just toss them out, the inbreeding coefficient would skyrocket even further, and we'd likely just introduce completely new unseen genetic diseases. We desperately need their genetic diversity.
So how do we handle this safely? Section 5, Safe Breeding Strategies. Let's look at some highly actionable, empowering protocols for you, the mare owner.
Let's look at the math here. Safely mating a carrier sire to a non-carrier dam gives you a 0% chance of an affected, sick foal. 0. The foal might end up being a carrier itself, or a non-carrier, but it will be 100% physically healthy. But if you breed a carrier to a carrier, that's when you hit the red zone. You suddenly have a 25% chance of an affected foal. And that right there is exactly why testing your mare is completely non-negotiable. Consider this your ultimate protector's checklist before breeding season even starts. Step 1. DNA test your mare. Honestly, it's super easy. You just pull a hair sample, make sure the root is intact, and send it to a lab. Step 2. Select a low kinship, tested stallion. You want to make sure he is totally negative for any trait your mare might carry. And Step 3. Work with the registry to calculate the mating so that the resulting foal's inbreeding coefficient stays safely under 5%.
So, the crucial point is this. In the past, breeding was basically a shot in the dark. It was blind selection based purely on aesthetics, chasing that perfect black coat and the high-stepping movement. But the future of Friesian breeding, it's all about combining that phenotypic excellence with rigorous genomic clarity. We have the data now. We literally do not have to guess anymore. And that leaves us with one final thought. You now know the history, you understand the very risks to your mares, and you've seen the absolute game-changing power of genetic testing. So, with modern DNA tools and registry guidance right at your fingertips, how will you step up to protect the magnificent legacy of the Friesian horse? Thanks so much for hanging out with me to explore this explainer today. I hope you leave feeling empowered, informed, and completely ready to make the best possible decisions for the future of your herd.